Hello everyone, my name is Eli Wools, and today, on October the 6th, Sunday, we'll be going over appropriate training prescriptions to promote anaerobic adaptations. Okay, first, what is anaerobic? The word anaerobic describes processes exhibited in the human body that don't require oxygen. Bioenergetic systems that do not require oxygen include the phosphagen system and the fast glycolysis process. These two bioenergetic systems create ATP without oxidation of energy substrates. Because exercises that target these systems are usually short-duration, high-intensity exercises, muscular and neuromuscular adaptations tend to accompany the metabolic adaptations. The phosphagen system uses two single-step equations to create ATP, which is broken down through hydrolysis to release previously stored energy in the chemical bonds. The reason behind this system producing ATP quickest is the fact that it is a single-step process and not a multiple-step process such as the Krebs cycle or glycolysis. But also it is limited in duration because of the limited amount of substrates that is stored in the body at a given time. For that reason, the duration of the PCR system is usually 1 to 10 seconds primarily. The first primary equation uses ADP and creatine phosphate to break apart creatine phosphate and add 1-phosphate to ADP to create ATP plus creatine. And this equation is catalyzed by creatine kinase. Glycolysis forms ATP through several reactions instead of just one, which reasons why this process takes longer to create ATP for energy. However, there is also more of an abundance of glucose than there is ATP or creatine phosphate in the body, which reasons why it also produces more. Following the end of glycolysis, pyruvate is formed and may be used in two different ways depending on the energy needs at the moment. If the energy demands are higher, the pyruvate is converted to lactate in the sarcoplasm, where it is shuttled to the liver and turned into glucose through gluconeogenesis, where it may be then shuttled back and start glycolysis over. The second, if the energy demands is relatively low, pyruvate gets shuttled to the mitochondria, where it undergoes the Krebs cycle and electron transport chain with the use of oxygen, and is the reason why this is termed slow glycolysis for the long duration of the Krebs cycle in comparison to glycolysis or phosphagen reactions. Anaerobic adaptations. Metabolic adaptations due to anaerobic training include increased storage of ATP, phosphocreatine, and glycogen. Muscular adaptations due to anaerobic training include increased hypertrophy of type 1 and type 2 fibers because of the size principle, where in order to activate the type 2 fibers, usually type 1 fibers will be activated. This is even disregarding the fact that type 1 fibers are usually associated with their oxidative capabilities. Besides this, there is increased myofibrillar volume. Neuromuscular adaptations due to anaerobic training include increased motor unit recruitment, which causes motor units to fire more frequently, and also increased synchronization of firing, lead to both strength and power increases. Enzyme activity of creatine phosphokinase, myokinase, phosphofructokinase, ATPs all increase, which leads to metabolic processes occurring quicker or more often. Besides this, there's an increased area of the neuromuscular junction, which is the connection between the motor neuron and the associated motor fibers, which possibly leads to augmenting rate of force development. Performance following adaptations. Due to these listed adaptations, muscular strength, muscular endurance, maximal rate of force production, vertical jump ability, anaerobic power, and sprint speed all tend to increase. An increase in any of these aspects would presumably lead to an augmentation in performance during competition that is dependent on power or explosiveness, which emphasizes the importance of promoting anaerobic adaptations. Causes of anaerobic adaptations and training prescription. These adaptations that have been previously listed occur due to the stress and energy demands that are placed on the body during exercises and are associated with a term specificity, as our body reacts acutely to the exercises that we are involved in. If the energy demands are not high enough, then the oxidative system will be primarily used and said adaptations will not be acquired. Additional stress must always be present in the human body to leave homeostasis and cause the body to adapt to the newly incorporated stress, and is known as progressive overload. Stressors that may cause these adaptations to arise include maximal sprinting, resistance training, med ball throws, plyometrics, or any form of exercise wherein maximal force is used during a limited duration. Resistance training. Resistance training may be incorporated into a program in order to acquire these desired adaptations. However, the rep scheme, intensity, and volume should all be considered. As found in an article by the Strength and Conditioning Research Journal, maximal strength had a direct correlation with that of training volume, which implies that trainers or professionals should be aware of weekly volume and if they acquire tremendous decrements in volume, which might lead to regression. The rep scheme should be adjusted lowly because following a duration of longer than 1 minute, the oxidative system will start to be used more than the PCR or glycolysis system. Due to the rep scheme being low, the intensity should be relatively high to increase motor unit recruitment. The intensity of the load might be most beneficial in a range of 80 to 95% of a 1 rep max. Also, one study by the Human Performance and Sports Science Laboratory found that taking an exercise through a fuller range of motion caused more neuromuscular adaptations in the involved individuals. Sprint training. Although running is almost always associated with cardiovascular abilities, sprints ran at maximal intensity during a short duration are primarily targeting the anaerobic systems. Adequate time, however, should be allowed to replenish the substrates lost during each set. To emphasize this claim, a study by the Journal of Strength and Conditioning tested the difference between short shuttle runs and long shuttle runs, and discovered that short-length shuttle runs created significant anaerobic adaptations, while long shuttle runs favored aerobic adaptations. Further training considerations and prescriptions. In conclusion, when desiring anaerobic adaptations, the training intensity prescribed should be at least 65% of a given maximal value. Adequate rest periods should also be included, ranging from 3 to 5 minutes to allow the anaerobic bioenergetic systems to replenish used energy substrates such as ATP or creatine phosphate. To emphasize this theory, one study by the Strength and Conditioning Journal investigated the difference between 1 minute and 3 minute interset rest periods. Following the investigation, it was found that the 3 minute rest group elicited greater strength and the hypertrophic increases.